Homework 6, Section 3.4, Logical Arguments, Video 3. As stated in the last video, we're going to set up the compound statement if premise 1 and premise 2, then conclusion, build its truth table, and answer the question, is it a tautology? Is it always true? And here was our argument written symbolically. Speaking of written symbolically, let's see if we can write this compound statement a little more symbolically because it's loaded with connectives. For example, the statement that we're checking to see for a tautology is a conditional. If, then. So we can start with an arrow. Warning, I'm going to change that arrow slightly in a moment, but you can start by just writing a regular arrow. Now let's see what's on both sides of it. On the right side, it's easy. It's the conclusion. So I'm just going to write the word conclusion as the consequent of this conditional. On the left side, though, we have a disjunction. We have a conjunction. And conjunction is the symbol that looks like an A without the line through it. Remember, it looks like an A and starts with A. On either side of this conjunction, we have premise 1 and premise 2. I'm just going to put P1 and P2 for the premises. And because the antecedent of the if-then is a compound statement, in other words, the statement between if and then is compound, we're going to put parentheses around it. This is going to be our setup to check if an argument is valid. We will replace each premise with whatever it happens to be and replace the conclusion with whatever it happens to be. Now, back to this symbol. It is a conditional, but a conditional in the middle of an argument with premises on the left and a conclusion on the right has a slightly different look. It's a double-lined arrow. It's still a conditional, and it still follows the same rules for conditional. The only time it's false is when T points to F. But in the midst of an argument, this conditional is called an implication. In fact, this entire statement is called the implication for an argument, and specifically an argument with two premises. Implying that there can be arguments with more than two premises. It wouldn't change much. You would just put another conjunction and then premise 3. And if necessary, another conjunction and then premise 4. We won't go beyond 3, and we'll rarely go beyond 2 premises. Okay, so let's set up the implication for this particular argument that we've already written symbolically. The implication for this argument is going to be, open parentheses, first premise, but because this premise is a compound statement, it needs to go in parentheses. So first premise, conjunction, second premise. Our second premise is just the simple statement P, so there are no need to put parentheses around it. After the second premise, close the parentheses. Conditional, implication, but it follows the same rules as a conditional. And then conclusion. Our conclusion is just the simple statement Q. So in the homework, when it asks you, what is the implication for this argument, it's asking you to set up a statement of this structure, the conjunction of the premises, pointing with a double line arrow to the conclusion. And if any premises, in the first video, I said that the plural, the singular for premises was premises. Now I'm thinking it's premise. I'll double check it here. In fact, I'll double check it now. Silly me. All right, correction. The singular is premise. The plural is premises. I'm not quite sure why I got clicked on what I was saying earlier. Let me fix that here. Premise, singular. Premises, plural. I must have been thinking nemesis versus nemesis, which are singular and plural. But for our vocabulary, singular is premise, plural is premises. I digress. We are going to set up a truth table for this implication and see if it's a tautology. If it is, that means that the argument is valid, because that means that this statement is always true, which means that this conclusion must always follow from these premises. All right, time to set up a truth table. Now, recall the protocol for setting up a truth table. You start with one column for each letter. We only have two letters, P and Q. Then we need one column per connective in the correct order according to the hierarchy of logical connectives. That hierarchy begins with parentheses, so we start here. And inside these parentheses, there's another set of parentheses. So we're going to start inside the innermost parentheses where there is only one connective. It will get done first. So that will complete the inner parentheses, but it won't complete the outer parentheses, because within them is still a connective, and so that conjunction will happen second. That completes the connectives inside all the parentheses, so we move outside of them and there's only one other connective. So we only need three more columns. We need one for the conditional. On the left is P, on the right is Q. One for the conjunction. On the left is the parentheses, which contains P pointing to Q. And on the right is just simple statement P. And our third column will represent the conditional, the implication, which on the left has that gigantic parentheses, which I may or may not fill in just a moment, and on the right side is Q. Let me check the time real quick. I want to keep the videos relatively short. This video is just past the 8-minute mark, and I know it's going to take a little bit of time to complete this table. So we're going to go ahead and end this video, but the next one will immediately resume with completing this truth table.